All right, we're in chapter 3 on the fundamentals of algebra. So this is section 3.1 on mathematical expressions. So we need to recall first a variable is a symbol, usually a letter, that stands for a value that may vary. The common ones we use are x and y, but any variable or any letter should work. Now, a mathematical expression, what is that? Well, when we combine numbers and variables in a valid way, using operations such as addition, subtraction, multiplication, division, exponentiation when you take exponents, and any other operations and functions we have not even covered yet, then the resulting combination of mathematical symbols is called a mathematical expression. So, what does it look like in just layman's terms? Well, it looks like these things, 2x. 4a plus 2, x cubed plus 7x squared minus 9x plus 10. Okay, so each one of these is an expression. Now, what are things that are not expressions? Well, this would not be an expression because a plus divide by each other doesn't make any sense. Now, if you had 2 plus 5 divided by 5x, okay, that would work. But that plus divide is kind of a no-go thing. You can't have two symbols like that next to each other. Now this one, it starts off good, 2 plus 3 times 2, and then it's kind of like we forgot to put the rest of the expression down. Now if we had had something like 2 plus 5x and then in parenthesis, then that would be fine. But you can't have a starting parenthesis and not have anything beyond that and just have an opening. So that's not an expression. And so what we're going to do is we're going to do translations. We're going to take word phrases and convert them into mathematical expressions, simple little things, like the 4a plus 2 or something. And we're going to do that with four different things we usually use: sums, differences, products, and quotients. And so sums, in a written expression, it might say find the sum of, or this is greater than this, or more than, or plus, or larger than. All of those indicate you're going to do some kind of sum. Now, differences, which means subtraction, sum, differences, products, that's multiplication, and quotient, well, that's going to be division. So that's our four things. Differences, we look at things like difference of, less than, subtracted from, minus, smaller than. All of those would indicate we're going to do some kind of subtraction or difference. Then products, the multiplication, well, that means we're going to take the product of, we're going to take times, twice, thrice, quadrupled, and so on. And then quotient, well, we're going to take the quotient of, we're going to divide it by the ratio of. Those are the most common ones for the quotient. So let's look at some examples where we basically are just going to convert some word sentences into a mathematical expression. So it says, the width of a rectangle is 5 inches shorter than its length. Express the width of the rectangle in terms of its length. Well, so we know width is going to be usually labeled as W. So let's say W is equal to the width. And so it says the width of a rectangle is, so width is 5 inches shorter than a length. So the length minus 5 inches, because it's that much shorter than this, so we're going to have to subtract off 5. And so that would be our mathematical expression. And all they really want is, we want the in terms of W. So if we wrote that out, that's just L minus 5. That would be our expression that they're looking for. Because if you would actually have that W equals L minus 5, that's an equation. So they just want the expression part, the L minus 5. Now, how about the next one? A string is cut into two pieces. So if we think about that, we have a string and it's sliced in two pieces, okay? The first measures 12 inches. Okay, well, that's 12 inches. Express the total length of the string as a function of x, where x represents the length of the second piece of string. Okay, well, the second piece, it just said that was equal to x. So if we're just writing the expressions, how would we find out that total length of the string? Well, we would just take x plus 12, add those two together, and we get the length from here to here, because we have that piece is 12 inches, that piece is x inches, x plus 12. All right, how about the next one? 2 times the length of z. Okay, well, 2 times, and we're calling z as the length, but we don't care that length. And all we're going to do is we're going to say take 2 times z. We're just taking 2 times that length, which is z. Okay. What about the next one? 14 times the sum of the number n and 10. Well, this one looks like we're going to have a little more complex because we're going to take 14 times the sum of n and 10. Well, the best way to get that n and 10 together is put it in parentheses. And we're going to take the sum of n plus 10, that sum times 14. So if we want, we could put a dot here, but when we have 14 parentheses, the n plus 10, we know we're going to take 14 times that sum, okay? And so that's how we would directly translate this into this expression. And again, our expressions won't have equals or anything else. It's just an expression. How about the supply y quadrupled? Well, quadrupled, remember, is you're multiplying it by 4, and we have a y, so that would just be 4y. We're taking 4 times our supply, which is y, and we get the supply quadrupled. How about the speed u decreased by 30? Well, we're having some speed u, and we decrease it by 30. Well, if we decrease it by 30, that means we're going to subtract 30. And that would be our new speed, which is u minus 30. All right, how about 13 less than 5 times the number p? Okay, so we're going to take 13 off of this part here, 5 times the number p. So we'll take 5 times p, and 13 less than that would be we subtract 13. And that then would be our expression 5p minus 13. Okay, now here we have the speed w increased by 32. Well, here we had the speed u decreased by 30. So if we take the w and increase it by 32, that means we're going to have to add 32. And so then that would be our speed w increased by 32. All right, I'll pause here and come back in a little bit.